They also observed the effects of surface electric fields and ions from the solar winds on the lunar surface, and determined the internal structure of the moon from variations in its magnetic field.
Well, in a nutshell, what we're finding is that the polar craters are very unusual electrical environments. Well, the solar wind is actually a relatively tenuous gas that's emitted from the sun, but it's not a neutral gas like the gas in this room. It's actually a gas that's really, for the most part, free ions and free electrons. So as you pass by, for example, a polar crater, the electrons will actually fill into the crater ahead of the ions. Now, as it turns out, as it does that, you create an electric field. It's called an ambipolar electric field, and that electric field then drives in the ions.
These hidden troves of water ice and other volatiles in the polar craters may be protected by a dangerous electric charge of hundreds of volts.
Three, 2, 1, 0, and liftoff of the Delta II with Grail. Journey to the center of the moon.
Grail consisted of two probes called Ebb and Flow. Linked together in a single flight path, they studied the gravitational field of the moon, generating maps like this crustal thickness atlas. It reveals much about the interior of the moon and even has some surprises.
2 years ago, we reported evidence that the moon is shrinking. Now we've found evidence that the moon is actually being pulled apart, forming features called graben. So the shrinking moon, it turns out, is not shrinking everywhere. Some places the moon is actually expanding by a little bit. So finding these young graben was a real surprise, because we thought, well, all these lobate scarps are telling us the moon is shrinking. So what are these little small graben that are telling us the moon is pulling apart doing in this picture? How does this all fit together? All that's related to how the moon has evolved, how the moon has lost heat over its 4.5 billion year history. Most of the terrestrial planets, when they formed, were very hot, and they got so hot that they actually completely melted. When that happens, they will be in a general state of contraction because they're still hot on the inside and cooling down. And as they cool, they want to shrink. Only the outer part of the moon melted, forming what is called a magma ocean. And in that model, the balance of stresses or forces that are acting on the moon would allow us to form both these small lobate scarps that show contraction, as well as these small graben that show the moon being pulled apart. One of the really, really exciting returns of the Lunar Reconnaissance Orbiter mission is that we've seen this now growing evidence of very young geologic activity on the moon.
The moon's crust is much thinner on the near side, 68 kilometers thick on average, and varies from less than a kilometer under Mare Crisium to 107 kilometers thick just north of the crater Korolev on the lunar far side. The moon's mantle is only partially molten, and the moon's center of mass is offset by about 2 kilometers in the direction toward the Earth. This and other data quickly changed our understanding of the moon. To gather more evidence on the unusual electrical properties on the lunar surface and how it affects lunar dust, NASA sent LADEE, the Lunar Atmosphere and Dust Environment Explorer, to investigate.
At higher altitudes, we saw very few dust particle impacts, but the lower we went with LADEE, the more we saw, and it's a very, very steep rise. So if you're operating with spacecraft very close to the surface of the moon, as you would with a robotic lander or a human lander, you might need to consider the fact that you've got more dust there in the way as you come in.
This probe flew progressively lower and finally impacted on the surface.
Ignition, throttle up, main stage. Passing.
This is Morpheus, a robotic self-guided lander. You tell it where to land, and it will do the rest, independently seeking the safest course and avoiding any rocky dangers. The ESA were also developing an autonomous lander to perform the same function.
The lunar lander is a small but very challenging mission. The most important part of it is, of course, landing on the south pole of the moon, which requires innovative solutions concerning landing, hazard avoidance, navigation, and in fact, this is the mission which will bring about the new generation of navigation and guidance sensor, algorithm, and software.
But a fiscal year is a long time in space. NASA now have little interest in returning men to the moon. They are firmly focused on a Martian landscape. The Europeans have had budget cuts. The ESA lander now shelved for the time being. This leaves the door wide open for Russia and the younger players, China, India and Japan, plus several private companies now developing the same technology to put first robots, then humans on the moon. All this time, the Chinese National Space Administration, or CNSA, had launched 2 orbiter reconnaissance satellites, Chang'e 1 and 2. Then Chang'e 3 deposited a lunar rover on the surface. Their latest, Chang'e 5, made a return trip around the moon. They are firmly set on a permanent manned lunar base.
I think the reason this has resonated with so many people and all over the world, it's not just our country, is because everyone can look up in the sky and see the moon. And I think a lot of people remember the Apollo landings, the first, man on the moon, and you can also look up at the sky, and I believe that people, it's very tangible to them that way. The moon, they can relate, and so they want to be a part of it. That's my theory on why people have just so connected.
The moon is indeed a tantalizing prize. The Chinese have their lander and rover there now. Japan and India will be next. South Korea has an interest along with Russia, Canada, France, Italy and the United Kingdom. Private enterprise has had a prod with the Google Lunar X prize. The $30 million prize pales beside the glory of being the first private company to land a robot on the moon and to explore at least 500 meters and transmit high-definition images back to Earth. So far, there are 4 hot contenders. The Barcelona Moon Team, a consortium of companies headed by Galactic Suite Design. Their interests lie in space technology and industry with a strong focus on tourism. Penn State Lunar Lion Team. Faculty and students are developing a spacecraft to land on the moon, then lift off again and relocate to fulfill the prize requirements. Moon Express is a group of space and Silicon Valley entrepreneurs looking to mine the moon for its valuable resources like platinum, titanium, and the rare isotope helium-3. Finally, Astrobotic Technology, a Pennsylvania-based company with support from other companies including Alcoa and Caterpillar. They have already reserved a launch on a SpaceX Falcon 9 launch vehicle. Getting to the moon is one thing, staying there is another.
It was one thing to go for a handful of days in Apollo and go when you knew that the sun was quiet, or you hoped the sun stayed quiet, and you took the risk, you calculated the risk of cancer and such, and you made a short mission. You're going to live there longer, you need to understand it well enough to go, here's what I need to do to protect myself.
One of the things that we're looking for in the LRO mission is how the high radiation environment affects our ability to explore. So if we bring cameras or communication devices, how will they be impacted by the cosmic radiation? We need to protect our equipment as well as ourselves.
We want to be able to go back to the moon so that we can live there for long periods and work on the moon. So we need a mission that can help us find the best places to go and determine how to go back there safely.
Access to solar power continuously, that may be the first and most important reason over the near term. And then the possibility of resources being there. Those may take much longer time before we're able to really exploit those. But the solar power is something we can exploit right away.
whether it's water ice to have water, or potential minerals that we could use as raw materials to make into things that we would need.
All the major players have designed and planned many varieties of lunar bases. NASA, ESA, and private contractors have concepts on the drawing board. As more information comes in from the lunar satellites on the environment, resources, and dangers of cosmic radiation, these plans evolve. One of the latest is to use 3D printing technology. With all the challenges and difficulties, many have made firm commitments to establishing bases within 10 to 15 years. Some for scientific research, others for commercialization and tourism. Some would choose not to send test pilots and scientists, but stewardesses and sommeliers.
When we look back on what we did in LRO and we look at what followed, I think we'll see a profound impact. We'll see us as really being the small first step where we have human beings permanently off this planet, beginning to move out into the solar system, starting with the moon. As that pans out, I think we'll be a small piece of a profound development that when history looks back, say this time we went back to the moon, this time we stayed, and we moved on from there.
As we continue to study the moon, our understanding of it improves, giving us new insights not only into how it has evolved over time, but also how other rocky planets in our solar system have come to look the way they do. With new missions, new instruments and new technologies, we will continue to improve our knowledge of the moon and better understand the history of our solar system.